Welcome to a new RKB Bearing Industries educational video, where we deal with the RKB Tough Roller technology and the advantages it introduces under heavy load conditions. The technology beneath RKB Tough Rollers is based on using high-quality forged steel to produce solid spherical, cylindrical and taper rollers from 30 mm diameter on. In most cases, to manufacture standard rollers for rolling bearings, continuous cast steel bars are used. The bar selection is followed by a series of other technological operations such as cutting, turning, heat treatments, grinding, polishing, sorting and preserving. Anyhow, rollers can be produced by means of a more technological process implying two more operations, hot forging and soft annealing. The hot forging of steel bars provides RKB Tough Rollers with better mechanical properties and ensures top quality bearing performance. In this movie clip you can see the starting steps of the RKB Tough Roller manufacturing process. Firstly, we select the continuous cast steel bars depending on the final diameter of the rollers we want to manufacture. Secondly, the selected bars are cut into smaller pieces in order to be correctly forged. The maximum diameter of the forged bar is 105 mm, with a length of 1500 mm and a proper forging ratio of 1.822 by 1. This illustration shows the weighted comparison between the characteristics of continuous cast steel and RKB forged steel. As is evident, the specifications of the RKB forged steel are superior to those of continuous cast steel in the matter of chemical and structural integrity. In fact, by eliminating internal voids and gas pockets and dispersing segregations and non-metallic inclusions, the forging process provides our forged steel with superior chemical uniformity. This leads to a better temperability of rollers, which in turn leads to better mechanical properties and dimensional stability. The typical uniform hardness reached by RKB Tough Rollers varies between 61 and 63 HRC. The forged steel used by RKB for the manufacture of its tough rollers offers benefits related to the roller manufacturing process, the corrosion, wear, fatigue, and the stationary load resistance, and the use in critical applications. The forging process gives our tough rollers a degree of structural integrity that cannot be achieved by the continuous casting process and enables the correct performance of machining and heat treatment operations. The near lack of internal discontinuities and surface inclusions in the RKB forged steel provides a reliable machining base for the turning process. Here you can see the application of the magnetic particle inspection method to RKB Tough Rollers in RKB T3 manufacturing plant. In this way we guarantee our bearings premium reliability and performance. RKB Tough Rollers have a properly developed grain flow that closely follows the outline of the component shape. On the contrary, standard rollers, having no directional flow, expose grain ends and are more subject to fatigue and more sensitive to stress corrosion. Thanks to the corrosion resistance offered by our forged steel, in RKB Tough Rollers any damage would spread 3 times slower than in standard rollers. By mechanically deforming the heated steel bars under tightly controlled conditions, the forging process produces predictable and uniform grain size and flow characteristics. Moreover, through the forging process, the steel bar structure is refined and defects and porosity are removed. These qualities lead to the superior mechanical properties and higher wear resistance of RKB Tough Rollers, being that they are also less susceptible to solid contaminants. The directional strength of RKB Tough Rollers is a direct result of the forging process. In fact, while forging, the controlled deformations of the steel bar result in improved mechanical properties of the material, such as mechanical strength, ductility and resistance to impact and fatigue. By forging the continuous cast steel bars, we intentionally orient the fiber flow lines in the direction that ensures maximum strength. In case of stationary bearings, due to micro-movements and/or resilience of the elastic contact under cyclic vibrations, there is always the risk that false brunelling appears. This phenomenon manifests as shallow depressions on bearing raceways or rolling element contact surface, and can often be discolored reddish or shiny. In RKB Tough Rollers, the chance that these depressions will form is much lower than in standard rollers, thanks to the improved mechanical properties of the RKB forged steel. RKB bearings with tough rollers can be used in critical applications where deflection, tilting and misalignment are likely to occur. On the contrary, due to the lower structural integrity given by the continuous cast steel, bearings with standard rollers are not recommended to be used in such applications, where temperature and wear tend to rise drastically. In fact, the excessive temperature would decrease the standard roller's hardness, speeding up the bearing failure process. RKB Tough Rollers are most of all mounted on bearings used in applications that require low operating speed and a high load capacity. As you can see from this technical fiche by the RKB Technical Department, they are typically spherical roller thrust bearings series 292, 293, 294 with medium big size inner diameter. To evaluate the benefits offered by RKB Tough Rollers compared to standard ones, we used finite element analysis in ANSYS environment. We analyzed an RKB Tough Roller and a standard roller from a thrust bearing 292630EM from the point of view of stress distribution, total deformation and safety factor. As is common knowledge, stress is equal to the ratio between the force and the section area to which it is applied. By applying the same force of 150 kN to both rollers, we obtain the same equivalent von Mises stress. It is of around 390 megapascals. For a better understanding of the stress distribution in the rollers, we show simulations for both standard type and RKB type. The main differences between the RKB Tough Roller and the standard roller lie in total deformation and safety factor, because the steel used by RKB has better mechanical properties such as Young modulus, Poisson ratio, tensile yield strength, compressive yield strength and ultimate yield strength than standard steel has. Therefore, as is evident from these graphs, the total deformation is higher in the standard roller than in the RKB Tough Roller, respectively 0.045 mm and 0.035 mm. Finally, always owing to lower mechanical properties, the standard roller has a safety factor of 2.7. That is lower than that of the RKB Tough Roller, which is 3.3. This means an improvement of almost 20% of the safety factor. Summarizing, the RKB Tough Roller technology ensures better chemical and structural integrity, higher wear and corrosion resistance, better behavior in critical applications, and higher safety factor. All these qualities lead to the higher reliability and performance of our rolling bearings. The RKB Tough Roller technology is particularly suitable for the bearings used in applications such as power transmission equipment, ball mills for thermal power plants, big size calendars, extruder equipment, and more.